Okay, welcome everybody. Today we're going to talk about Calc Lesson number 19. This is day 4 of the chain rule, but specifically we're going to talk about using the chain rule to find equations of tangent lines and to find what's called the second derivative, so very exciting. To start off, find the equation of the tangent line to the given graph at the given point. Now, we've been finding equations of tangent lines for a while now, but we haven't yet done it with a problem involving the chain rule. It's not really any different besides the fact that you have to obviously use the chain rule. So I figured doing one with you would probably be a good idea. Remember that in order to find the equation for a tangent line, you need the slope of the tangent line and you need the point of tangency. So I already have the POT, the point of tangency. I'm going to have to now go ahead and find the slope of the tangent line. That, of course, means the derivative. So because of the fact this is f of x, I'm going to call my derivative f prime of x. I'm going to use the power rule, which means I'm going to bring down the 3. I'm going to take the entire quantity, 2x squared, plus 1 to the 1 less power, which would of course be 2. And then don't forget to use the chain rule. Taking the derivative of the inside, the derivative of 2x squared would of course be 4x, and the derivative of a constant is 0. Clean that up just a bit. So my equation here for the derivative would be 12x times 2x squared plus 1 squared. Now that I have that, remember, I'm going to need the slope of the tangent line, which means I have to find the value of the derivative at whatever this x value is. So I'm going to find the value at x equals -1. So finding the value of the derivative means I'm going to find f prime of -1. So 12 times -1 times 2 times -1 squared is +1 plus 1 squared. That's going to give me -12. And then 2 times 1 is 2, plus 1 is 3, squared is 9. So that is going to give me the SOT, which is the slope of the tangent line, which if you multiply -12 times 9, you're going to get -108. So now that I have the SOT, the slope of the tangent line, and I already have the POT, the point of tangency, I'm going to put those together as y equals mx plus b. So I'm going to go ahead and do that on the next screen. So y equals mx plus b. So the y is 27. The slope is -108, -1 for the x, and then plus b. So 27 equals 108 plus b. So subtract 108, b is going to equal -81. Put that all together, and the final equation for the equation of the tangent line would be y equals -108x minus 81. Obviously, those numbers are relatively large, but it matters not since we're not graphing them. Again, you have found the equations of plenty of tangent lines, but now just make sure that you know the chain rule is always an option, no matter what the problem is asking for. The second thing I want to talk about today is the idea of finding what's called a second derivative. Technically, every derivative you have found so far is called the first derivative, so we don't really need to refer to it by that yet, but once we get to chapter 3, there'll be very important information that we can find out about the graph from the first derivative, and then very important information that we can conclude from the second derivative. So in order to find the second derivative, it basically just means finding the derivative twice using the chain rule as needed. So here, in the first example, using the second derivative, I have 8 over x minus 2 squared. Just like always, I'm going to go ahead and do a rewrite step where I'm going to say 8 times x minus 2 to the -2 power. Again, that is simply a rewrite step, which is why it's still f of x. When you take the derivative of f of x, we're going to call that f prime of x. And again, this is technically called the first derivative. So you're going to bring down the -2. -2 times 8 would be -16. Then you're going to do x minus 2 to the 1 less power, which would, of course, be -3. A note about the chain rule here, if you were going to use the chain rule, the derivative of the inside would just be 1. If the derivative of the inside with the chain rule is just 1, there's no need to write it. So again, just because the chain rule is an option doesn't mean you have to use it every time. You just have to keep it in mind. Normally, if we were just finding the first derivative, we would simplify this answer, but because we now want to find the second derivative, we're actually going to leave it in that form. We're going to call the second derivative f double prime of x. So you do have to be cautious with your notation. 1 tick mark means the first derivative, and 2 tick marks means the second derivative. And then you're just going to apply the power rule a second time, bring down the -3. -3 times -16 is positive 48. Again, make sure you go to the one less power. The chain rule would just have a derivative of 1, which means no need to do it. In our final answer, you should simplify just like we've been doing. You should make sure that all your like terms are combined and all of your exponents are positive. So the second derivative is equal to 48 over x minus 2 to the fourth. You might be wondering, well, is there a third derivative or a fourth derivative or a fifth derivative? Here's the thing. You could take the derivative as many times in a row as you want, but only the first and second derivative actually mean anything. Once we get to chapter 3, both the first and second derivative have major implications for the graphs and the functions. The third derivative and fourth derivative, even though you could find them algebraically, they don't mean anything, so we really won't ever go past the second derivative unless you just want to do so for funsies. Let's go ahead and do one more. So find the second derivative, and again, using the chain rule as needed. So this is one of those problems where you kind of have to look at the big picture. Is this a trig problem or is it a squared problem? And it turns out that because the outside function is sine, this is actually a trig problem. So as I go to take the first derivative, the derivative of the sine of something is the cosine of the same something. And then you have to take the derivative of the inside, which means you have to take the derivative of x squared. And again, that's using that fancy notation. I tend to like to use it whenever there's trig involved. You still have an option at this point, whether you're going to use it or not. So then the derivative would be equal to the cosine of x squared. The derivative of x squared is 2x. Normally, we put our 2x in the front, so I'm going to go ahead and do that. And then remember, this is just the first derivative. I now want to find the second derivative, which means I'm going to have to go another round. Take a look at this problem. Just like in the original, how the big picture was this is a sine problem, the big picture now is the fact that this is now a product problem. That happens a lot when it comes to second derivatives. Even if the first derivative is relatively simple, the second derivative can escalate quickly. We probably would make it no harder than this one, but just make sure you're aware that oftentimes the first derivative is straightforward, where the second derivative is a little bit more work. So on the next screen here, we're going to go ahead and find the second derivative using the product rule. So f double prime, which again means the second derivative, that's going to be my first, which is 2x, times the derivative of the second. So the derivative of the cosine of x squared is the negative sine of x squared. Then you would have to use the chain rule. So the derivative of the inside would be 2x. So again, this is really the first, and then this whole thing is the derivative of the second, plus the second would be the cosine of x squared, times the derivative of the first. The derivative of 2x would just be 2. And again, if you're still using the ff prime, gg prime, first times the derivative of the second, plus the second times the derivative of the first. So feel free to keep using that as long as it's helpful. Little bit of simplification here. So if we look at the first term, I'm going to take the 2x, and the negative. That's going to give me a negative 4x squared times the sine of x squared, and then plus 2 cosine of x squared. From here, in my final answer, we would probably take the answer as is. The only thing you could factor out here would actually be a 2. So if you went ahead and factored out the 2, you would get negative 2x squared times the sine of x squared plus the cosine of x squared. And again, just to be clear, both of these versions, here and here, would be perfectly acceptable. Remember, as we head towards the next assessment, you will always be able to ask your teacher, should I go farther? Did I go far enough? Should I simplify? Should I factor? And we will be happy to answer those questions. So that's really all that was left from 2.4. So you're going to go ahead and try homework 19 tonight. It's only these 5 problems. The first 3 are asking you to practice those tangent lines. There are some trig in there. So remember, if you're using your calculator, make sure that you are in radian mode as long as you're entering pies and whatnot. Otherwise, feel free to refer to the unit circle and the trig reference sheet. The last 2 problems are asking you to find the second derivative. So again, make sure you're using the proper notation and make sure that you are watching for the chain rule and whether or not it becomes a harder problem. So thanks very much for tuning in, guys, and we will catch you next time.